Alright, let's read this problem. Assuming bicycle tires are perfectly flexible and support the weight of a bicycle and rider by pressure alone, calculate the total area of tires in contact with the ground if a bicycle and rider have a total mass of 80 kg and the gauge pressure in the tire is 3.5 times 10 to the power 5 pascals. Alright, so let's draw a diagram first. Okay, I'm just going to draw the wheels. I'm not even going to attempt to. Alright, so here's the air pressure in the tires, okay. And here's the contact, the area of contact. This plus this is the area of contact of the tires to the ground. Okay, and alright, I'll complete the diagram. Alright, there's the bicycle. Now the weight to be supported is mg, where m is 80 kgs. Okay, so this force, that's the force of gravity on the bicycle, and the only other object in contact with the bicycle is the ground. Okay, so the force, these two combined forces, the force that the ground exerts, this F, since okay, I'll say F1 plus F2. The force that the ground exerts on the bicycle should be F1 plus F2, and it should equal the magnitude mg, since the bicycle is not going into the ground. Alright, so the force that the ground exerts should be equal to that. Okay, now if you look at this piece of the tire, these pieces of the tire, they're not moving, so the force due to the air pressure should balance the ground force. And now there's two pieces. I'm not going to write all of that. So what that amounts to is the absolute pressure in the tires times the area of the tires in contact with the ground should equal the ground force, should equal mg. Okay, so absolute pressure times the area should equal mg. So what are we trying to find? The area of, what we're trying to find is the total area of the tires in contact. So we're trying to find A. So A is mg divided by the absolute pressure. And what we are given in the problem is gauge pressure. So we will have to add atmospheric pressure to that. Alright, before we do that, let's add a page. Okay, so area equal to the weight to be supported divided by gauge pressure plus atmospheric pressure. Alright, let's put in numbers. 80 kgs divided by times 9.8 meters per second square, and the gauge pressure is given to be 3.5 pascals, and so gauge pressure is 3.5 times 10 to the power 5 pascals, and atmospheric pressure is 1 times 10 to the power 5 pascals, Newton meter squared. Okay, and so this will kg, meters per second square, cancels the Newton, you get a meter square on top. So that'll give you the area of the tire in contact, okay, with the ground. So 80 times 9.8 divided by 4.5 into 10 to the minus 5 meters square, and we'll borrow 1, so it's 8 times 9.8, 4.5 into 10 minus 4 meters square. And the reason I wrote that is because this is centimeter square, this right here. Okay, so the area in centimeter square is so that's roughly a square of side 4 times 4 would be 16, so roughly a square of side 4 centimeters, which is roughly an inch and a half. Okay, so that's how much. So picture a square of size inch, 1.5 inch on the side, and that's how much area of the bike is in contact with the ground. Okay, that does that problem. Let me make sure, is there anything else? Yep, no, that's it. Okay, so let's stop this video.